Welcome to a new episode in my home automation OpenHAB and Node-RED series. In this video, I'll look at how to capture images and videos from IP cameras, store them, manage them, and email them in Node-RED. To keep this video shorter, I will not talk through all the code. Mostly, I will just explain how the flow works and how you can adapt it to your needs. As always, you can find the links in the video description. First of all, let me give an overview of the setup. So as always, we have Node-RED in the middle. In my case, it's a Raspberry Pi, but of course it can be a different hardware. So we have a computer which is running Node-RED, and then of course you have IP cameras, which can be your IP cameras or can be some public IP cameras. For example, you want to get an image of the feed around your, the roads around you, so you know what the traffic looks like. And so obviously the two are connected together. And we are talking about, or I'm going to only focus on IP cameras that use the RSTP stream instead of sending images or some other different format. And on the Node-RED or on the same machine, we will have a software which can convert this RSTP stream. There are many different versions, or like ffmpeg. On the Raspberry, there is another one which is called the AV-conv. So we will feed this RSTP stream into this conversion program, and the result will be sent to local storage, database, files, or Twitter. What I want to do in Node-RED are the following. So I want to be able to capture single frames or fixed length videos from the RSTP stream. I want to be able to monitor the progress just to make sure that I am capturing the frames in case I'm running some background processes which I wouldn't be monitoring normally. I want to embed the images and the videos into the dashboard as far as it's possible. I want to store information in the database, generate reports so I can see how files got generated from various devices and in various types. I want to be able to send emails with attachments of the images, well, maybe even videos, but probably it's more practical with images. I also want a variant of that where you can generate multiple images and then put them into one single email. And then finally, maybe as another output, post the images to Twitter. Before we dive into the Node-RED details, and by the way, this is the Node-RED flow, and it looks quite big, but actually it is quite simple. We need to talk about some of the software basics because we need some sort of application or component to install to convert the RSTP stream into either an image or just grab a portion of that video. And as I said, on Windows and probably on other machines, we have ffmpeg as a package to convert pictures, videos, anything. And on Raspberry Pi, we don't have ffmpeg, but we have another one. So if you open your Raspberry terminal and if you just do this sudo apt-get install and libav and -tools, I mean, for me, it's not going to do anything because it's already installed, but that's going to install the component that you need, and you will be able to call the application to convert it using this av-conv command. And if I do, what is it, /h? Yeah. Then you can probably see it is a very extensive one. And I don't claim that I understand how it exactly works in terms of like all the different options and the things that you can have. Basically, I was doing a lot of Googling and I was trying out a lot of different options. And then finally, I managed to get to the version or basically a command which grabs the image for me and then grabs the video for me. Hopefully it is going to work for you as well. If it doesn't, please don't ask me because I wouldn't be able to answer. Just Google or find the relevant forum where there are people that know a lot more about this AV-conv than I do. And I don't know what's the connection between ffmpeg and AV-conv, but all the Google results I got for ffmpeg in terms of the command line, the parameters and everything, it seems to work in AV-conv. So that made me happy. So that's only one thing, or that's only the first requisite that we need to do. The other thing we need to do is we need to create like a static folder that can be published. So that you have the UI. So if I open up the UI, and so when you create a new dashboard items, it appears in the UI and it gets integrated into the UI, so it's all nice. But what I also wanted to do is, for example, I wanted to do this when I grab a frame, I want to put it into a folder, and I should be able to reference to this image here instead of running a separate Apache web server. And actually, this can be done in Node-RED. So if I open up the Node-RED config, which is I hope I will be able to find it now. It's probably in the Node-RED folder. I should probably look for it. Yeah, so it's the settings.js. So you can find this section here in the settings.js, which says HTTP settings static. So by default, it's commented out. And I created a new folder which is called Node-RED static in my home/pi. And anything that I put into this folder, so for example, if I go out and if I go up and into this Node-RED static, so for example, I have a grep on JPEG. So if I come here and then just the HTTPS, because I have HTTPS configured. So it's the IP colon 1880 and then grep.jpg. Then you can see the image. So that folder now becomes the root folder of my web server. Well, I guess that's the correct way of saying that. So that's the first thing that you need to do. So edit your create a folder, edit your settings.js, set this HTTP static parameter, and then you need to restart Node-RED. And after that, any file that you put into that folder, it should appear. You should be able to reference it in the using the URL through port 1880. So that's it. Okay, I think that's all about the prerequisites, and now we can go back to the Node-RED flow. The idea, again, as I said before, we had to install the avconf component to get the file, the stream converted to an image or a video. And basically, I'm going to use that in that flow. And the heart of the whole flow is this exec command, which is going to call the avcom with various parameters. So if I go right to the beginning, then you can see that it's avconf, and I have an RSTP stream. So actually, let me copy this into a notepad. So this is the parameters that I use for converting an image. So avconf -e for input, and then you put the RSTP, the full RSTP address, obviously with user ID and password. And then the next parameter is -frames1 and -qscale1 and -f image. And then right at the end is going to be the output image path, the full path. And so the reason you don't see it here, because I'm going to pass that in the message payload. So it is important that you take this one. So whatever comes in the message payload gets appended to the end of the command, and that's how the command will get executed. And to look at a very simple scenario, I have a button, sorry, an inject node here, which doesn't really do anything, or I have a button on the UI, which is this one. And then all it does is sends the it sets the payload to a specific file name. So it's the /home/pi/Node-RED static and grab one JPEG. And if you remember, I just opened up. So grab, yeah. So it looked like this. This is something that I've done, yeah, a couple of days ago. So if I trigger this, you see that the process has started, and it takes a couple of seconds, or it probably depends on various IP cameras. But even if I open the same stream in VLC, it takes a couple of seconds to open. But it saved that file, and if I refresh now, we should see a different image. Yeah, so this is now today, and the sun, we don't have sun today. So this would be the most basic way of creating a picture. So in my example, you pass the file name in the payload, and then you call the exec with the command where it doesn't have the output file at the end. So we just append it using the message.payload, and then that's it. It creates the file. So we don't really have to do anything else. I output the results into a template node. So I have a template node which basically formats the image. But what I've noticed that if I refresh the UI, it gets refreshed, but otherwise it doesn't get refreshed automatically. Maybe the UI can see that the source hasn't really changed, even though the underlying file has changed. But I mean, the dashboard probably doesn't know that, so it doesn't upload the doesn't update the image. So now you can see it's a different image now, and I just put a link in below which opens up the image in full screen, because otherwise, well, you can display it full screen here, but it's just probably too big. So that would be the most basic functionality here, just to create one static image. And just for debugging purposes and see what's going on, I have put this message stuff here, but probably can remove that. And also the second output, I redirected to a file. And that again would be important for testing, because if something goes wrong, especially with this AVConf program, the output is huge. So it's so big that you can't see the whole output in the debug window. So if you redirect it to a file, something goes wrong, you can look at the file and see what's what's happening. But again, probably you can remove that if once your solution is stable and you don't need to create a file every time you create grab an image. So that part would be the most basic way of grabbing an image. And by the way, I'm talking about RSTP streams, and I found the open source camera security software. So if you download this one, this probably has like hundreds and thousands of different cameras in the listed as the different features, and then the addresses that the camera supports. So if you have something which is like a cheap Chinese knockoff camera, something similar to what I have, and they don't document the RSTP feed address, then you can download this video and say that, okay, this is my IP IP of my camera and the user ID and the password, and it goes through all the different combinations. Basically, it tries every single address from its library. It takes about like 15 to 20 minutes, but eventually it will give you an RSTP feed if it can find one. So that's quite useful. So that was all about how you find the feed address, the feed address for your camera. Next, what I wanted to do is I wanted to just make sure that it's this whole frame grabbing application is working, and like the camera is connected. We can connect to the camera, we can receive pictures. So I created this set of nodes here, which create a statistics that you can also see here on the UI. So all it does, it's every time I call this exec node, the third output, which is the result output, gets sent to this function node, and it basically counts the number of inputs, and then it counts the number of times the result code was 0, which means that the command managed to execute without any errors. And it just gives you a few statistics. So you can see that I have grabbed 60 frames up until now. 86% was successful. The other failed for various reasons. And the last time I did it is actually a couple of minutes ago when I did that. And you have a inject node where you can reset the statistics. So if you want to do it daily, monthly, you can set it up to fire at a specific time or specific intervals. And just have some statistics on your page, so you know what's going on in the background. And the next what I wanted to do, so I'm going to make this a little bit smaller, is I wanted to enhance that functionality. So not only that I create like a single image which gets overwritten every time, but maybe I add a timestamp to a file name, and then once the file is created, then I can also store it in a database. I can move it, I can email it, I can email multiple images. And that's what I've created here. So these top 3 nodes would be the most basic solution, or the most basic implementation of this process. And if we go a little bit further, then it gets a little bit complicated. So I created this function node, which looks a little bit complicated, but you can ignore most of it. And all this is used for is to set some simple input parameters. So it sets the path where the file needs to be stored. It sets the file name where the file name of the JPEG file that it will be created. So in my example, it's going to be called frame underscore, and the year in year, month, date format, and the time in hour, month, second format. So I just use this format because if I look at the files in alphabetical order, then it's the same order as the how it was created. And then I have a few more stuff, like I put the whole file name and path into a separate parameter, and then also the file name into a separate one, and the path, and also like the www, so the web path. So because my HTTP static folder is this folder, for the web server, this is the root of the web server. So later on, when I generate the URL for the image, I need this path to go in front of the file name in order to generate the correct URL. Next one is I set the topic. So the way I've constructed this whole flow is here you specify how you want to grab the image, like where you want to store it and what would be the file name, but also what do you want to do with the image once after it's processed. And the way I did it is that you put like special commands into the topic, and those commands get evaluated here. So if I put store, then here this node is going to say that, okay, I wanted to store this image, so it's going to grab the file name and it's going to store it in the database. If I do email, then, oh, I want to create an email, so it generates the email, it grabs the file and puts it into an email. If I wanted to delete the picture after it was taken, then it again grabs the file name and deletes the file, deletes the image. And also the same with the Twitter, so it grabs the email and then posts it onto Twitter. And the way I did it is, again, as I said, it's in the topic. So in the most basic one, if you just put the word store in the topic, then the file gets grabbed and then it stores in the database. So for example, if you want to do some time lapse with your IP camera, where you create a snapshot of I don't know, every single day, like you have a small business and then you have a camera pointed to your parking lot, and you want to see who arrived to the office 8 o'clock in the morning, you can use this. You can use the inject node to set it up again as a specific interval, and it will just take a picture every time and then store it in the database. But again, as I said in the beginning, it doesn't have to be your feed. It can be a feed of your traffic camera from highway that you need to pass through every morning. So you can have this image taken every single morning and maybe email it to you so you can see how the traffic looks like before you go. There is also a type parameter, which again will be used later on in the reporting. So that's something which goes into the database, and you have, and then the last two is again just formatted dates and times that get passed and get used later on. So okay, I'm not going to launch it just yet. I also want to describe the other end of it. So once the file is grabbed, we can see that the result goes to the statistics, and then also on the output it goes to all these nodes, which are basically the post-processing nodes. And the save DB is really simple because it saves the information into a database. And at this point I should probably show the database as well. If you have seen my previous video, you know that I have a Node-RED database where I store all data from different sensors, and I've created a new table here which is called the NVR. And if you want to look at the structure, then you can pause the video and get the structure from here. I also, if I don't forget, I put it into the video description as well. But it's rather simple. We have a key, an ID field, which is auto-incrementing ID. Then we have a type, and this is the type which comes from here. So it's basically just a string, and this can be something like, you know, front camera, garden, something like that. Anything that you, anything that helps you to remember that, you know, type of, let's say, image. The next one is the path and the file name, which obviously the physical path and the file name of the file. We have the www path, which is the you know, relative path for the URL, and we have the epoch, which is the time when the image was taken in the Unix format, and also we have the timestamp, which is in a more readable format. So if I look at the database, it looks something like this. And you can see the timestamps here. If you look at the database here, you can quite easily read the time instead of reading the Unix timestamp and then the file names and the other stuff. And the reason I did this, I'm going to jump a little bit forward, because I also wanted to add a little bit of reporting functionality where you can you know, look for videos in the last, let's say, last 24 hours, 7 days, 30 days, and then you can see the, well, not systems, but yeah, the types, whether it's like a front camera capture or a time lapse or a, you know, video test, which is actually a video, not an image. And again, it's the reason we needed the www path, because if I generate this URL here that you can see, so obviously it doesn't have all the home/pi/ other stuff in it, so it just should have a slash, because that's the root for the web server. I hope it all makes sense now. So going back to the flow, all this function does is just generates the SQL for the database. So it, yeah, just creates it saves the image data into the database, and also gives you like a timestamp when it was last used. And if probably I should reduce the resolution so we see a little bit more. So if I do that, and if I just grab a frame, again, it fires off the exec node, and then once it goes out, once it finishes, we should see the timestamp updating here on the save function node. Yeah, it happened already. And if I go to the, so you see, well, the last one is 16th of September, and if I update, then now we have a 22nd of September and the sun is out. So that's the simple one. And the next one is, okay, I want to grab an image and I want to send it as a picture. So this function node is exactly the same, but what I'm doing here is I have so I set the type as a front, just to you know, set something different, and this time the topic is store and email. So I just put a pipe in between, but it can be like any different characters, because all the logic looks at is that whether the word store or whether the word email is actually in the topic. And the email part of it is again fairly simple. So anything which comes out of the exec once the image is created goes through all these nodes, and then they just check, or do I need to save, do I need to email, and each of these nodes will fire. So the email one is again really simple. If I have the word email in the topic, then it puts the file name together and it goes to this next node, which looks a little bit complicated, but all you need to care about these two, which is here the topic, which becomes the subject of the message, and the payload, which becomes the body of the message. And then it goes into an email node. And if I fire it, then I need to wait a little bit, and I got an email, which looks a little bit funny. So this is the first time I did not manage to grab a full image. So let's just take another one to see if this is a reproducible issue. Okay, and this time it looks, you know, fairly normal. So that's the email functionality. And again, because I put store an email, if I refresh this, I should see the two new images appearing here. So you can see these images here as well in the in the reporting side of it. Of course, if I would only put email into the topic, then it wouldn't get stored in the database. It would just grab the image and then put it into email, and that's done. So the next thing I wanted to do is I wanted to implement something which is quite often found in these IP cameras, that if there is a motion detected, then it sends not only one but maybe like 3 images a couple of I don't know, maybe 10-15 seconds apart. So this is what I try to implement here. So you have 3 image nodes, and they are all linked together, so the output goes into the input of the next one with like a 15-second delay. So when you put an input here, then the first image will get taken, and the second one after 15 minutes, and the third one after, well, half a minute after the first. And I did it again using the topic, so using a separate topic. So I have a topic which says free mail, which, like, you know, free images and email, and /1 saying that this is going to be the first one. And then I have a free email /2, so that's the second image, and then a free email /3. So it's going to take 3 images. And then I have this node which looks for this for the free mail, and then when it notices that it's /1 and /2, it just stores the file name, the full file name. And when the third one is also taken, then it just puts all this information together and then sends it out to a very similar email node. So it looks exactly the same. You have a topic and the payload, which is the subject and as the message body, and the image will be taken. And so now we use the first image, and then the delay has also started, and then the second image the capturing of the second image will trigger, but the email part is not doing anything yet because it's still waiting for the email. And what you have also noticed is I also put this delete here and didn't put any store. So this will take 3 images, it will email them, and then it would also delete the 3 images after the images were taken or the email was sent. And again, this is done here. You don't really have to understand the whole code, but the only reason this code is a little bit complicated because it caters for deleting a single image or deleting 3 images after the third one is received. And I put like a 15-second delay. As you can see, it's now started and I'm probably already completed. And that 15 seconds delay is only required just to make sure that I don't delete the images before the email is sent out. So we have captured 3 emails, and if I refresh this one, you don't see any updates here because we didn't put the store into the topic. But if I go back to my emails, shoot, and it just happened again. It really didn't happen me once. Damn. So I received the email with the 3 images, and you can see that they are definitely different images because this one is 211:31, and then, okay, we can't see that, but the last one is 212:01. So they are really, you know, 3 separate images taken one after the other. This is not nice, and I really don't know how I'm going to solve this issue. But for now, let's go back to the flow. And last one is tweet a frame. So again, the topic is going to be somewhat different. So the topic contains the tweet and the delete. So I want to grab an image, tweet it, and once it is tweeted, delete it. And then again, the flow is very simple. It goes through the exec, and here it goes to this tweet one. So it checks whether the topic contains the tweet, and it sends out, it reads the file that was saved, and it sends out to a tweet. So this is how you, based on the documentation, this is how you put a tweet together. So you put your text to the payload, and you put your image into the media, and the image is in the payload because it's just coming from this file node. And the reason I have all these different debug nodes here, because it's not working, and I can't really figure out why. So I just followed the instructions here and the info here. So you put the, you know, the media, the image into the media, and I only get the text. I don't get the image in Twitter. So again, it's something to be completed in the future. But I guess hopefully you get the whole idea how, you know, I designed this whole thing and how you can enhance it and then, you know, customize it to your needs. And obviously for each of these, I just use a simple inject node, and then you can, you know, change it to to fire a specific interval, or you can use it as any other trigger. And as hopefully you can see that from this code that this doesn't really care what the input message is. So you can redirect any trigger like MQTT, or it can be even an email, and then just link it to here, and then it would just start the process, whatever it needs to do. So it doesn't really care what's coming in. It doesn't have to be like a specific message to start the process. And we haven't finished with the flow, because there is another part of it, which is the second part of it, which is going to be almost exactly the same as the top one, but we are going to capture a video. And for capturing the video, notepad, so we are going to use a slightly separate command. So it's again avconf -e, the RTSP. I always say RSTP, but it RTSP stream URL and /R10 and /T30, and the R is the frame rate, and my camera doesn't do more than like 8 frames per second, so I just set it to 10. Maybe this is not even required. T30 is the length of the image, so it's going to be like a 30-second video. And then Y is to override the last file, and then V codec copy means that instead of transcoding the video, we just copy the video into the MP4 output. And as far as I know, all of the IP cameras that are available nowadays, they use H.264 for encoding the video, which is something that the MP4 container accepts. But if your camera is something different, then you probably want to look at this V codec and then just specify what the transcoding is supposed to be. And the AN at the end is going to be the output file name. So again, what I do here is I just just say that it's the video.mp4, or here it's again video underscore the timestamp.mp4. But again, the rest is exactly the same. So all the things with the emailing and storing and everything, which I explained here, works exactly the same for video, because these nodes don't really care what the file looks like. Well, maybe the Twitter obviously wouldn't accept the video as a tweet, and for the email, like a 5 meg video would be a little bit too much, but you can use it exactly the same way as I did it for the image. So in the payload, you pass the file name, which gets appended to the end of the command, and then again the output goes to a template node, which obviously doesn't display the video, it just generates a link. And then yeah, we also do the statistics. And so I have a separate statistic here. Well, I have only done one. I have only done one single video up until now. So if I click it now, then obviously this exec command is going to run for, well, for the image it took about 5-6 seconds for me, so it's probably going to be like a, I don't know, 35-40 seconds for it to complete, and then we should see the video statistics updated. And I clicked on this one, which is going to store this in a database, and it does it because the output from both of the video capture and the frame capture goes to this dummy one, and then all these at the same time. So all the functionality that you get for images, you can get for videos as well. So it's completed, and yeah, we have 2 videos. And then if I refresh, I should have the MP4, and then yeah, we can see the video. And there are some issues with the feed, so probably my camera would need some sort of, I don't know, maybe I just need to restart it. I haven't noticed this before, I swear. So that will be the video part, which works exactly the same as the image part. The only difference is basically the command. And last is 2 small things, is the statistics. So this part of the, let's say this report part is here. It's nothing really special. So I have a couple of filters. You can filter on the date and you can filter on the type. I should rename this system to type. And then once you make changes to these, then the system generates a URL. Sorry, the system generates a SQL select, and that SQL goes to the database, goes to that table, and the output gets formatted. And that's pretty much it. And of course now it's here in the formatting node is where I need the ww path. So as you can see, the URL is the w path plus and the file name. So that's the reason I needed to store that differently, and this is why it also needs to be specified here in all these input ones. So it's like a slash. And I'm not using this, but that would be my, let's say, really simple archiving strategy, or just making sure that the folder where the videos or the images are stored are not going to grow without any control. And it's a very simple implementation, because all it does, it creates a SQL which looks up anything which is older than 30 days. And the way you modify this is that you change this last value. So the epoch is in seconds. Sorry, milliseconds. So it's 1000 is 1 second, 60 is a minute, another 60 is an hour, 24 is a 1 day, and then times 30 is 30 days. So this will select anything which is older than 30 days. It run it through the database. The database will select all the items, and then I wasn't sure what would be the best way of deleting, because deleting the entries from the database is really simple, but deleting the files, it can be only one file, it can be like 50. So what I decided is that every single file will get deleted separately. So this is why I do a split, because the SQL node is going to return an array of which contains all the records from the database. So I split it into separate messages. I put this random in, so if you have like 50 files, then the system doesn't start executing 50 exec commands at the same time, but just splits them up randomly between 50 and 500 milliseconds interval. And basically I just take the payload, sorry, the path and the file name from the database, I pass it to the payload, and I execute rm command, which is the Linux for deleting a file. So if you use a different OS, then you need to change this one. And again, I append the message payload at the end of the command, so it gives me the full, sudo rm and /homepy/ something and then .jpeg. And I tested it and it works. So it deletes the files, and also it deletes deletes those single records from the database. And I think that's the end of the flow. Finally, let's look at what we have learned from this video. So the results are that it's relatively easy to capture RSTP streams using the exec node. It's also possible to implement a fully featured NVR within Node-RED, but since the NVRs are pretty cheap nowadays, maybe it's just easier to buy a dedicated hardware and just use Node-RED for some of the vanilla features. For some reason, I failed to post a proper Twitter tweet. I can get the text in, but not the image. I couldn't figure out what the issue is as of now. Maybe there is a problem with the node, but I'm not sure. So if there is going to be any progress on that, you will probably see it in the comment section. One important to note is the SD cards have limited lifetime. So if you want to use this flow to, create a lot of images and a lot of videos, maybe you should consider to get an external hard drive and then use that to save the images. It's probably going to extend the life of your SD card. And if you run it on a daily basis or some regular intervals, also keep in mind that it can really fill up the space either on your SD card or your external hard drive. So always implement some sort of archiving policy, something simple like just deleting anything older than 30 days or 2 weeks, depending on your use. I think that would be pretty much on this topic. Thanks for watching, and hopefully see you in the next video.